Hello, in this lecture we will find the radius of a circle. In the picture you can see circle. Inside the circle we have chord AD that is 10 units in size, and we have also chord BC that equals to 5 units in its size, and the center of the circle is at point O, and the angle ALB equals to 90 degrees, and we want to find out the radius of this circle, or the size of the radius of this circle. Okay. First of all, we will define what is a peripheral angle. Okay. Peripheral angle. A peripheral angle is an angle that its vertex is on the circle and its curves are strings in the circle. So if we have a circle and a peripheral angle so actually alpha is defined as a peripheral angle because its vertex is on the circle, point A. In point A we have the vertex of this peripheral angle, and its curves are strings in the circle. Curve AB of the angle is a string in the circle, and also curve AC of the angle is a string in the circle. Okay, so alpha is defined as a peripheral angle because its vertex is at point A, is a point on the circle itself, and its curve AB is a string in the circle, and curve AC is also of the angle is also a string in the circle. Okay, so I will read again the definition of a peripheral angle. A peripheral angle is an angle that its vertex is on the circle. The vertex of peripheral angle alpha is point A, that is a point on the circle itself, and its curves are strings in the circle. The curves of angle alpha, of the peripheral angle alpha, are strings on this circle. Curve AB of the angle alpha is string in this circle, and also curve AC of angle alpha is a string in this circle. Okay, so again, a peripheral angle is an angle that its vertex is on the circle. Vertex A is on the circle, is a point on the circle, and its curves are strings in the circle. The curve AC of the angle alpha is a string in this circle, and also curve AB of this angle alpha is a string in the circle. Okay, so that is the definition of a peripheral angle. Okay, so in the next step we will draw a diameter of this circle through points A and O. O is the center of this circle, so we will draw a diameter that starts from A through point O. Of course, all the diameters of the circle must cross the center of the circle, that is point O. Okay, so I draw a diameter through point A and O of this circle, and I will call the touching point between the diameter and the circle point M. Okay, M is the touching point between the diameter AM and the circle. So AM is the diameter of this circle. Okay, I will write it down. That string AM, string AM or chord AM or string, it is the same. Okay, it is chord or string AM is the diameter of the circle. Okay, again, the string or the chord AM is the diameter of this circle. Okay, in the next step I will connect together by a straight line points M and D. Okay, I connected together points M and D by a straight line, and actually we have a rule. I will call it rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter equals to 90 degrees. Okay, or I can say also that a peripheral angle that subtends the diameter equals to 90 degrees. Actually, if we have a circle and the center of the circle is here, and we have a diameter then any peripheral angle that rests on the diameter equals to 90 degrees. For example, this peripheral angle that rests on the diameter of the circle equals to 90 degrees. Okay, or any other peripheral angle that rests on the diameter equals to 90 degrees. This is also a peripheral angle that rests on the diameter of the circle. For that reason, it also equals to 90 degrees. Okay, so that is rule number 1. So according to rule number 1, angle ADM rests on AM, and AM is the diameter of this circle. Okay, AM is the diameter of this circle. AM is the diameter of the circle. Okay, string AM is the diameter of the circle, and because of the fact that angle ADM rests on the diameter AM, according to rule number 1, it equals to 90 degrees. Okay? So, because of the fact that angle ADM rests on the diameter or subtends the diameter is the same, because of the fact that angle ADM rests on the diameter, according to rule number 1 that I mentioned, it equals to 90 degrees. Okay? So according to rule number 1, and the angle ADM that rests on the diameter AM of the circle, it equals to 90 degrees. I will write here 90 degrees. Okay? In the next step, we will define angle AMD as alpha, and we will also define angle DAM as beta. Okay? And we know that the sum of the angles in any triangle equals to 180 degrees. It is a simple rule that you might know it. So the sum of the angles in triangle AMD or in any triangle equals to 180 degrees. So in triangle AMD, the sum of the angles equal to 180 degrees. That is to say, alpha plus beta plus 90 degrees equals to 180 degrees. Okay? Alpha plus beta plus 90 degrees, that they are the angles in the right triangle AMD, and the sum of these angles equals to 180 degrees. It is true for any triangle. In any triangle, the sum of the angles equals to 180 degrees. Okay, so alpha plus beta plus 90 degrees equals to 180 degrees. So we actually can substitute from equation number 1 90 or 90 degrees, and we will get that we can subtract from equation number 1 90 degrees. We will get that alpha plus beta equals to 90 degrees, because 190 degrees minus 90 degrees equals to 90 degrees, and alpha plus beta plus 90 minus 90 equals to alpha plus beta. Now we will subtract from the equation alpha, angle alpha. Okay, we'll subtract alpha from equation number 1. We will get that beta, angle beta equals to 90 degrees minus alpha. That is our first equation. Okay, I subtracted alpha from the equation. We got that beta equals to 90 degrees minus alpha. Okay, now I will connect together points A and B by a straight line. Angle ABD rests on the chord or the string AD, and angle alpha, that is AMD, also rests on the same string or the same chord. That is to say, it rests on string AD also. Okay, and we actually have rule number 2 that states rule number 2 states that peripheral angles that rests on the same chord or arc equal to each other. I will read again rule number 2. So rule number 2 states that peripheral angles that rests on the same chord / arc equal to each other. So I will give you an example that explains the meaning of rule number 2. So if we have two peripheral angles, the first peripheral angle is alpha, and we have another peripheral angle. beta. As you can see from the drawing, angle alpha rests on string BC, and angle beta also rests on the same string BC. So according to rule number 2, the peripheral angles alpha and beta are equal to each other. So according to rule number 2, alpha equals to beta because of the fact that the both peripheral angles rests on the same chord, or the same string, or on the same chord, BC. According to rule number 2, because of the fact that both angles rest on the same string or on the same chord BC, they are equal to each other. So alpha equals to beta. Okay, so we can implement rule number 2 in our circle, because we actually have angle AMD, that is alpha, angle AMD that equals to angle alpha, angle AMD equals to angle alpha, and it rests on the chord AD. On chord AD. Okay. Angle AMD or angle alpha rests on chord AD. Angle alpha or angle AMD rests on chord AD. And angle ABD also rests on chord AD. Okay, angle ABD also rests on chord AD. So we have angle alpha that rests on chord AD, and angle ABD also rests on the same chord AD. For that reason, according to rule number 2, angle ABD also equals to alpha. Okay, according to rule number 2, those two angles that rests on the same chord AD are equal to each other. For that reason, angle ABD also equals to alpha. So angle ABD rests on chord alpha. Angle ABD rests on chord AD. Angle ABD also rests on chord AB. For that reason, those two angles are equal to each other according to rule number 2. Okay, so according to rule number 2, angle ABD also equals to alpha. Okay? Because of the fact that angle AMD rests on chord AD and also angle ABD rests on the same chord, that is to say on chord AD, according to rule number 2, they are equal to each other, that is to say this angle equals to alpha, this angle also must equal to alpha. So angle ABD according to rule number 2 equals also to alpha because of the fact that both two angles rest on the same chord AD. For that reason they are equal to each other, so angle ABD also equals to angle alpha. Okay? So actually we will focus now on the right triangle ABL. On triangle ABL, the sum of the angles in any triangle equals to 180 degrees. So if I define angle BAL as x, then we can say that alpha plus x plus 90 degrees equals to 180 degrees. Alpha plus x plus 90 degrees equals to 180 degrees, because in any triangle the sum of the angles are equal to 180 degrees. Okay, so we can subtract from this equation 90 degrees and we will get that alpha plus x equals to 90 degrees. Okay, we subtracted from this equation 90 degrees, we got that alpha plus x equals to 180 degrees, because 180 degrees minus 90 degrees equals to 90 degrees. Now we will subtract alpha from this equation, from this equality. We will get that angle x equals to 90 degrees minus alpha. So the second equation, we subtracted alpha from both sides of the equation. We got that angle x equals to 90 degrees minus alpha. Okay, but from equation number 1, we know that beta also equals to 90 minus alpha, 90 degrees minus alpha. So I write it down according to equation number 1. So according to equation number 1, angle beta equals also to 90 degrees minus alpha. Okay, according to equation number 1, beta also equals to 90 degrees minus alpha. Okay, so 90 degrees minus alpha equals to 90 degrees minus alpha. Okay, the further question is that 90 degrees minus alpha equals to 90 degrees minus alpha. Then we'll substitute 90 degrees minus alpha in this side of the equation by x, and we substitute 90 degrees minus alpha by beta on this side of the equation, and we will get that angle x equals to beta. Okay, we subtracted 90 degrees minus alpha by x from this side of the equation. We subtracted 90 degrees minus alpha with beta from this side of the equation. We got that angle x equals to beta. Okay, so actually we can substitute x in the right triangle ABL by beta, because x equals to beta. That's what we get. That's what we got. That x equals to beta. So I write here that angle ABL equals to beta. So actually we have two angles that equals to beta, and according to rule number 1, rule number 3 states that peripheral angles that equal to each other rest on equal chords. So I will read rule number 3 again. Rule number 3 states that peripheral angles that equal to each other rests on the same chords. So I will explain this rule. If we have two peripheral angles, let's call this angle peripheral angle alpha, and let's call this peripheral angle beta. So if alpha equals to beta, if those two angles are equal to each other, then they rest on equal chords. We can deduce from it, according to rule number 3, that string or chord AB equals to chord CD, because equal peripheral angles rest on equal chords. Because of the fact that peripheral angle alpha equals to peripheral angle beta, we can deduce from it that according to rule number 3, that chord AB equals to chord CD. Okay? And we actually can implement rule number 3 in our circle. So actually we have angle DAM equals to angle BAC equals to beta. Okay, this angle equals to beta. So according to rule number 3, we can deduce from it. According to rule number 3, we can deduce that chord BC equals to chord MD. Because equal peripheral angles rests on equal chords. That is to say, because of the fact that angle BAC equals to beta equals to angle AMD that also equals to beta, we can deduce from it, according to rule number 3, that the angle that chord BC also equals to chord MD, because equal peripheral angles rest on equal chords. That is to say, BC equals to MD. Okay, according to rule number 3, chord BC equals to chord MD because angle MAD equals to angle BAC equals to beta. Equal peripheral angles rest on equal chords. So BC equals to MD. But we know it is given us in the question that chord BC equals to 5 units. Okay, BC equals to 5 units because it is given us in the question. Okay, BC equals to 5 units, and we know that BC equals to MD. Okay, so we can deduce from it that MD also equals to 5 units. Okay, MD equals to 5 units. Okay, so MD equals to 5 units. So we actually have right triangle AMD. It is right triangle because of the fact that angle ADM equals to 90 degrees. And we can use Pythagorean theorem in order to find out the value of the hypotenuse. The hypotenuse is also equals to the diameter of this circle, and then we will divide the diameter by 2 in order to find out the radius of this circle. Very simple. Okay, so as you have already know, the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so it is the Pythagorean theorem. So the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we actually can implement this theorem in our right triangle. I will draw again the right triangle AMD. So this is the right triangle AMD. Angle AD equals to 10 units. Angle MD, we found out that it equals also to 5 units as angle BC. And I called to the diameter AM D, abbreviation of diameter, and it is very easy to find out the diameter. The diameter equals to 2 times the radius, and then we will divide the outcome of the size of the diameter by 2 in order to find out the radius of the circle. Okay, so according to Pythagorean theorem, AM squared that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, equals to md square plus ad square. Okay, according to Pythagorean theorem, am squared, the square of the hypotenuse, that is actually the diameter of the circle. So the hypotenuse squared, or the diameter square, equals to the sum of the squares of the perpendiculars, equals to dm square plus ad square. But we know that dm equals to 5 units and OA equals to 10 units, so we can put the data inside the equation, and we will find out that am squared, the square of the diameter, it is also the hypotenuse of this right triangle, equals to dm square, dm equals to 10, so it is 10 square, plus OA square, but OA equals to 5, so we can substitute OA by 5, and we get it is 5 square, so 10 square plus 5 square equals to 125. Okay, so am square equals to 125. Okay, 10 square is 100 and 5 square is 25. 100 plus 25 equals to 125. We will take out a root from this equation. We will get that the value of the diameter of the circle equals am, that is the diameter of the circle, equals to square root 2 square root of 125. But 125 equals to 25 times 5, yes? Okay, 125 equals to 25 times 5. And then, as you have already know, the root square of a times b equals to root square a times root square b, yes? So we can split this root to 2 roots. Okay, according to the rule that the square root of a times b equals to square root a times square root b. Okay, according to this rule, that square root of ab equals to square root a times square root b, we can write that the square root of 25 times 5 equals to square root 25 times square root 5. This equals to am. So according to this rule, we can divide the square to 2 parts. Square root of 25 times 5 equals to square root of 25 times square root of 5, but the square root of 25 equals to 5, so I write it down. Okay, so square root of 25 equals to 5 times square root 5 equals to MA. MA equals to the diameter of the circle. We defined AM as the diameter of the circle, yes, because it is a string that passes through the center of the circle. Okay, so AM equals to 2 times the radius. Okay, because of the fact that AM is the diameter of the circle, AM equals to 2 times the radius of the circle. So the radius of the circle equals to AM over 2. Okay, the radius equals to AM over 2. So actually we'll divide 5 times root 5 by 2 in order to find out the radius of this circle. So the radius of this circle will be equal to AM, that is 5 times root 5, square root 5 divided by 2. Okay, so we divided the diameter AM, that equals to 5 times square root 5 to 2, and we got that the radius of this circle equals to 5 times root 5 over 2. So actually that is the answer to the question, that the radius of this circle equals to 5 times square root 5 divided by 2. Okay, so now I will summarize the lecture. We actually wanted to find out the radius of this circle, and first of all, we actually defined what is a peripheral angle. A peripheral angle is an angle that its vertex is on the circle, like angle alpha. The vertex of angle alpha is on the circle, is a point on the circle, A is a point on the circle, and its curves are strings in the circle. Curve AC of angle alpha is a string in the circle, and curve AB of the angle alpha is also a string or a chord in this circle. So this is the definition of a peripheral angle. Okay, an angle that is vertex on the circle. The vertex of angle alpha is point A on the circle, and its curves are strings in the circle. So curve AC is the string of the circle, and curve AB of angle alpha is a string in this circle. Okay, so that is the definition of a peripheral angle, and we actually have in the circle chord AD that equals to 10 units, chord BC equals to 5 units. We know that angle ALB equals to 90 degrees and the center of the circle is at point O. Okay, then we draw a diameter from points A and O, and the touching point of the diameter with the circle, the second touching point is point M, because of the fact that string AM passes through the center of this circle. It is defined as the diameter of this circle. So AM is the diameter of this circle, and we connected together points M and D by a straight line, and actually we have here angle ADM, and according to rule number 1, so it is angle ADM is a peripheral angle, and according to rule number 1, a peripheral angle that rests on the diameter equals to 90 degrees. So we can implement this rule on our circle, because angle ADM rests on the diameter of this circle AM. Angle ADM rests on the diameter of this circle, that is to say, rests on string AM, that is the diameter of this circle. And according to rule number 1, any peripheral angle that rests on the diameter of a circle equals to 90 degrees. For that reason, according to rule number 1, angle ADM equals to 90 degrees. Okay? So, I repeat again on rule number 1, any peripheral angle that rests on the diameter, if the blue straight line is the diameter of the circle, then any peripheral angle that rests on the diameter equals to 90 degrees. So this angle that rests on the diameter equals to 90 degrees, and this angle that rests on the diameter also equals to 90 degrees. And according to that rule, angle ADM that rests on the diameter AM equals to 90 degrees. Okay? Okay, AM is the diameter of the circle because of the fact that angle ADM rests on the diameter, and according to rule number 1, it equals to 90 degrees. Okay? So, in the next step, we connected together points A and B by a straight line, and we actually have angle ABD. Angle ABD rests on chord AD, and we have also angle AMD that equals to alpha and also rests on chord AD. So we have two angles that rest on the same chord AD, and according to rule number 2, they are equal to each other. Actually, rule number 2 states that if two peripheral angles that rest on the same chord or arc equal to each other. So if we have two peripheral angles, alpha and beta, that rest on the same chord, both of those peripheral angles rests on chord BC. So according to rule number 2, peripheral angles that rest on the same chord equal to each other, because of the fact that angle alpha rests on chord BC and angle beta also rests on the same chord BC, they are equal to each other. According to rule number 2, alpha equals to beta. Okay, so that is rule number 2. Okay, peripheral angles that rest on the same chord equal to each other. So we actually have two angles, angle AMD, that is angle alpha, rests on chord AD, and angle ABD also rests on the same chord AD. So according to rule number 2, they are equal to each other. So angle ABD also equals to alpha. Okay, actually from the beginning, we defined angle AMD in the right triangle AMD as alpha and angle DAM as beta. Okay, so angle AMD equals to alpha according to our definition, and angle DAM equals to beta according to our definition. And because of the fact that angle AMD rests on chord AD and angle ABD also rests on the same chord AD, they are equal to each other. So if angle AMD equals to alpha, angle ABD also equals to alpha according to rule number 2, that if two angles rest on the same chord, they are equal to each other. Those two angles rest on the same chord, that is to say on chord AD, therefore they are equal to each other. So if angle AMD equals to alpha, angle ABD equals also to alpha, because both of them rest on the same chord, that is to say on chord on chord AD. Okay, so according to rule number 2, they are equal to each other. So angle ABD also equals to alpha. Okay, and we will focus first of all the sum of the angles on triangle AMD equals to 180 degrees. So actually angle alpha plus angle beta plus 90 degrees equals to 180 degrees, because we have general rule that in any triangle the sum of the angles is equal to 180 degrees. So the sum of the angles on triangle AMD equals to alpha plus beta plus 90 degrees. Alpha plus beta plus 90 degrees. This equals to 180 degrees, because in any triangle the sum of the angles equals to 180 degrees. We substituted from the equation number 1 90 degrees, and we got that alpha plus beta equals to 90 degrees. We substituted from equation number 1 here alpha, we got that beta equals to 90 degrees minus alpha. Okay, beta equals to 90 degrees minus alpha, and we will focus now on triangle A, the right triangle ABL. We know that the sum of the angles in any triangle equals to 180 degrees. So beta plus alpha plus 90 degrees equals to 180 degrees. This is the second equation. The sum of the triangles in the right triangle ABL equals to 180 degrees. It is true for any triangle in the world, especially for triangle ABL. So the sum of the angles in the triangle ABL equals to 180 degrees. Alpha plus x, we define this angle as x, as 90 degrees equals to 180 degrees. We substituted alpha from both sides, or we substituted 90 degrees from both sides of the equation. We got that alpha plus x equals to 90 degrees. Then we substituted alpha from equation number 2. We got that angle x equals to 90 degrees minus alpha. But from equation number 1, we know that beta also equals to 90 degrees minus alpha. Okay, so I wrote it here, that beta also equals to 90 degrees minus alpha. So 90 degrees minus alpha equals to 90 degrees minus alpha. We substituted 90 degrees minus alpha by x here, and we substituted 90 degrees minus alpha by beta here, and we got to the conclusion that angle x equals to beta. So here, instead of x, I wrote beta because angle x equals to beta. Okay, so actually we have here two angles that both of them equal to beta. Yes, and according to, actually they are peripheral angles, both of them peripheral angles that equal to beta, equal to each other and equal to beta. So according to rule number 3, peripheral angles that equal to each other rest on equal chords. Okay, so actually if we have two peripheral angles that equal to each other, if alpha equals to beta, then their chords also equal to each other, because of the fact that alpha equals to beta. According to rule number 3, also AB equals to CD. Okay, that is the explanation of rule number 3, that equal peripheral angles have equal chords. Because of the fact that alpha equals to beta, also chord AB equals to chord CD. And we can implement this rule in our circle. Okay, rule number 1 states that peripheral angles that equal to each other rests on equal chords. So we actually have two peripheral angles. Angle BAC is beta, and angle AMD is also beta. They are both equal to each other, and according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. So according to rule number 3, because of the fact that those two angles equal to each other, equal to beta, their chords also equal to each other. So BC equals to MD. BC equals to MD because peripheral angles that equal to each other rests on equal chords. That is to say, BC equals to MD. Okay? BC equals to MD, but it is given us in the question that BC equals to 5 units. That is something that is given us in the question. So we can deduce from it BC equals to MD and BC equals to 5 units. We can deduce from this that MD also equals to 5 units. Okay? And we actually have here right triangle. We can implement the Pythagorean theorem in order to find out the value of the hypotenuse AM, that is also the diameter of this circle. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? And actually I drew the right triangle ADM again, the square of the hypotenuse, that is to say AM square, equals to the sum of the squares of the perpendiculars. That is to say AM square equals to DM square plus AD square, or MD square plus AD square. Okay? But we know that AD equals to 10 and MD equals to 5, so we can substitute AD by 10 and MD by 5. Okay, so we put it in the equation, and we got that AM square equals to 125, and we took a root out of this equation. We got that the square root of MA equals to 125, but 125 equals to 25 times 5, and we have a rule, if we have two expressions that multiplied inside the root, we can split it to two parts. If we have a root of A times B, it equals to root A times root B. So instead of 25 times 5, we can write root 25, square root of 25 times square root of 5, all equals to AM. Okay, all equals to AM. And the square root of 25 equals to 5. I have here square root of 5, we left it as it is. So actually AM, that is the diameter of the circle, equals to 5 times square root of 5. Okay? What is the diameter of any circle? The diameter of any circle equals to 2 times the radius of the circle. Okay, so we can write that AM equals to 2 times the radius. Therefore, the radius itself equals to AM over 2. Okay, so AM that equals to 5 times the root of 5 over 2 is the radius of this circle. So the answer to the question is that the radius of this circle is 5 times root 5, square root of 5, over 2. Okay, the radius of this circle is 5 times square root of 5 over 2. That is the radius of this circle. Okay, thank you very much.